It's likely a gas giant almost as big as its nearest planetary neighbor, Neptune.
What if a mystery lurking at the very edge of our solar system wasn't just a theory, but real? Evidence uncovered by a quantum AI system and hidden in the data of the James Webb Telescope for years. Scientists have long speculated about Planet 9, a massive unseen world influencing the orbits of distant Kuiper Belt objects. Today, that speculation might finally be turning into reality. A breakthrough quantum AI system, processing deep field scans from James Webb, has isolated a series of gravitational anomalies and subtle infrared signatures that point to something big. NASA insiders are reportedly speechless, and the implications are nothing short of revolutionary. In this video, we're going to explain how this quantum AI system dug through layers of noisy data to reveal what could be the long-sought evidence of Planet 9. We'll break down the process, examine the data, and explore what this means for our understanding of the outer solar system and for astronomy as a whole. It all started with a treasure trove of data from the James Webb Space Telescope. Originally, JWST was tasked with peering deep into space, capturing infrared light from distant objects. In its many deep field scans of the outer reaches of our solar system, there were countless images of faint, seemingly insignificant objects. But hidden within these datasets was a pattern, a set of gravitational distortions and anomalous light signatures that had long been overlooked. Enter the quantum AI system. Unlike classical algorithms that sift through pixels one by one, this advanced system uses principles of quantum probability and entanglement to analyze patterns on a cosmic scale. For 72 continuous hours, it combed through terabytes of raw JWST data, calculating the likelihood of various light distributions and gravitational influences across the Kuiper Belt. The result? A recurring, slow-moving signal, a shadowy object whose gravitational pull was subtly distorting the orbits of surrounding bodies. Along with this, the AI detected a faint but consistent infrared reflection emanating from an area of space that had no known source. When scientists first saw the output, the system's final log read simply, "Anomaly confirmed. Candidate object detected." This output wasn't an over-enhancement of noise. It was a clear pattern emerging from the data, a pattern that matched theoretical predictions for what Planet 9 should look like. With a mass estimated to be between 5 and 10 times that of Earth, and an orbit that takes tens of thousands of years, this object could finally be the missing piece that explains the unusual orbits observed in the far reaches of our solar system. Before we dig deeper, let's revisit the history of Planet 9. First proposed in 2016 by astronomers at Caltech, the Planet 9 hypothesis emerged as a solution to a puzzle. Why do many trans-Neptunian objects have orbits that are clustered in one direction? The idea was that an unseen planet, a massive distant body, was exerting its gravitational influence, shepherding these objects into similar paths. For years, astronomers searched for direct evidence of this elusive world, but the vast distances and dim light made it nearly impossible to capture with conventional methods. The James Webb Telescope, with its cutting-edge infrared capabilities, promised to change that, but only if we could extract meaning from its enormous data sets. And that's exactly what the quantum AI system has done. This isn't your typical telescope image. The quantum AI isn't merely enhancing images. It's using probability fields to predict where the faint light from a distant object should appear, and then cross-referencing that with gravitational data. This method provides not just a single snapshot, but a dynamic model that evolves over time, a statistical reconstruction of an object that has long remained hidden in the darkness. As we explore this breakthrough, keep in mind that what we're seeing is the culmination of years of theoretical predictions meeting state-of-the-art technology. It's the product of an ingenious marriage between quantum computing and astronomical observation, a marriage that is reshaping our understanding of the cosmos. Now, what exactly could this mysterious object be? Scientists are currently split between two main theories. Theory A suggests the object is a conventional planet, a gas giant or an ice giant, somewhere between 5 to 10 times the mass of Earth. Its slow elliptical orbit takes it far from the Sun, which is why it has remained undetected for so long. This theory aligns closely with the original predictions of Planet 9, a massive body whose gravity would shape the orbits of countless smaller objects in the Kuiper Belt. Theory B offers a more radical possibility. It proposes that the object might not be a planet at all, but a primordial black hole, a remnant from the early universe. Though minuscule in size compared to a star, such an object could still possess enormous mass, exerting a gravitational influence comparable to that of a large planet. This theory, while speculative, gains traction from the unusual infrared signature detected by the quantum AI system, something that might indicate an object that doesn't emit light in a typical manner. Both theories are groundbreaking in their own right. If it's a gas or ice giant, we're looking at the discovery of a new planetary body that could force us to rewrite the textbooks on our solar system's formation. If it's a primordial black hole, then we're not just revising planetary science. We're confronting the possibility of exotic objects that bridge the gap between astrophysics and cosmology. Regardless of which theory is correct, the fact remains that the data points to the presence of a massive dark object in a region where nothing like this was expected. And that's a game changer. As if the discovery itself wasn't startling enough, there's an unexpected twist that has the scientific community buzzing. When the quantum AI system analyzed the object's movement, it noted that the gravitational influence of this body does not perfectly align with existing models. Instead, the object appears to wobble. Its motion shows irregularities that could hint at additional factors at play. One possibility is that the object has a small orbiting companion, a moon or even a ring system, adding complexity to its gravitational signature. Alternatively, the wobble might indicate that the object is surrounded by a field of debris, or that it's interacting with other unseen bodies in the outer solar system. Even more intriguing is a subtle, rhythmic pulsing in its heat signature. The AI detected a narrow band reflection that appears to pulse at regular intervals. While some scientists caution that this might be due to natural processes, others are left wondering, could this be a sign of artificial interference? While highly speculative, the idea that this object might be more than a mere planet, or even that it could be a remnant of an ancient engineered system, has ignited imaginations around the world. This twist forces us to consider that the outer solar system might harbor complexities far beyond our current understanding. Every wobble, every pulse of heat, every minuscule deviation in its expected orbit serves as a clue that points toward something truly extraordinary. Let's pause and reflect. We're standing on the brink of a discovery that could reshape our view of the solar system. Imagine for a moment that every gravitational nudge, every stray photon, every minute anomaly captured by the James Webb telescope is a message, a cosmic breadcrumb leading us to a new world. This is the kind of moment scientists dream about. It's not a definitive answer, but it's a tantalizing glimpse into a puzzle that has perplexed astronomers for years. The quantum AI system has given us a roadmap, a statistical reconstruction that hints at the existence of a massive unseen object that has quietly been influencing the motions of countless distant objects. What does this mean for our place in the universe? For the first time, we might be able to add a new chapter to the story of our solar system, a chapter that introduces a mysterious dark presence at its very edge. Whether it's a conventional planet or something far more exotic, the implications are profound. They extend from our understanding of planetary formation to the very nature of cosmic evolution. Digging deeper, let's consider another layer of speculation. Some theorists suggest that this object might not be isolated at all. It could be part of a larger unseen system. One hypothesis posits that Planet 9 could be a captured rogue planet, an interloper that was once part of another solar system and was gravitationally snared by our Sun. This idea isn't entirely new, but the precision of the quantum AI's findings gives it fresh credibility. Alternatively, there's speculation that the object might be the remnant of a dwarf star system. Perhaps a small star, long dead and collapsed into a dense core, wandered too close to the outer solar system and was captured by the Sun's gravity. This could explain some of the irregularities in its movement and the unusual infrared signature. If true, it would challenge our definitions of what constitutes a planet versus a stellar remnant. Across the scientific community, debates are heating up. Researchers are comparing the newly discovered anomaly with similar signals in other star systems, looking for patterns that might indicate a broader cosmic phenomenon. Is Planet 9 an isolated oddity, or does it hint at a common process in the evolution of solar systems? The data may even suggest that such objects are more frequent than we once thought, hidden in the dark, only now coming into view thanks to quantum computational breakthroughs. Every theory brings us one step closer to understanding the true nature of this mysterious object. And while the debate is far from settled, one thing is clear: our solar system may be far more dynamic and complex than we ever imagined. The quantum AI system didn't stop at merely identifying the object. It went a step further. In its final simulation, the AI predicted the object's current position with astonishing precision, narrowing its possible location to within a 0.3-degree margin. This level of accuracy is unprecedented, especially given the faintness and distance of the target. The simulation factored in not just gravitational data, but also minute variations in the infrared background and the subtle shifts in light patterns. Over time, the AI's confidence score was calculated at an astounding 97.2%, a figure that leaves little room for doubt. For the first time, we have a model that not only suggests the existence of Planet 9, but also tells us exactly where to look. In internal briefings, one leading astrophysicist was quoted as saying, "If this is what we think it is, then our models of the outer solar system need a complete overhaul." NASA's silence on the matter speaks volumes. This isn't a trivial update. It's a seismic shift in our understanding of our cosmic backyard. This final revelation ties together all the threads of our investigation, from the raw data captured by James Webb through the quantum AI's sophisticated analysis to the simulation that pinpointed the object's location. Every piece of evidence points to one conclusion: something massive, mysterious, and entirely unexpected is lurking at the fringes of our solar system. So, what does all this mean for humanity in our quest to explore the cosmos? This breakthrough is more than a technological milestone. It is a paradigm shift. For the first time, quantum AI and the James Webb Telescope have combined to give us an intimate look at the outer solar system, revealing gravitational distortions, infrared signatures, and even potential hints of artificial structures that defy conventional explanations. This is not mere speculation. The image and simulation are based on real, high-quality data reconstructed using state-of-the-art quantum algorithms that predict the behavior of light and matter at cosmic distances. It is a reminder that the universe is accessible to our inquisitive minds, and that every breakthrough pushes the boundary of what we consider possible. For scientists, this discovery paves the way for a new era of exploration. With these advanced imaging techniques, we may soon be able to catalog the physical characteristics of distant celestial bodies with extraordinary precision, rewriting the textbooks on solar system formation. For the public, it offers a glimpse into a future where the mysteries of space become increasingly tangible a future where the unknown is not hidden forever, but revealed in all its complex beauty. And while we have not yet found definitive proof of extraterrestrial intelligence, the possibility that one day we might detect techno-signatures on distant objects, like Planet 9, keeps our collective imagination alive. Every detail, every thermal pulse, every anomaly captured by this quantum AI system is a stepping stone toward a deeper understanding of our place in the cosmos. If this discovery changed how you see our solar system, you won't want to miss what's next. Subscribe and turn on notifications so you don't miss it. Before we wrap up, consider the revolutionary potential of this breakthrough. We now stand at the threshold of officially adding a new member to our solar system, a member that could force us to rethink our cosmic models and challenge everything we know about planetary science. In our next video, we'll dive into another astonishing discovery, an ancient star that shouldn't exist, and what its presence might tell us about the fabric of time itself. Stay tuned, because the journey to understand our cosmic neighborhood has only just begun.